Hello, and thank you for standing by, and welcome to the 7th episode of the World Series on Data Virtualization. Today's topic is on data virtualization for unified data services, featured Randy Heffner, VP and Principal Analyst with Forrester Research. My name is Kim Lukens, and I'm the moderator for the World Series on Data Virtualization. Please note that the webinar will be made available for on-demand viewing following the event. Denodo Technologies is sponsoring this series of expert talks on data virtualization throughout the rest of 2011. For today's presentation, I'd like to invite Suresh Chandrasekaran, Senior VP with Denodo Technologies, to share with you some key points to kick off this episode of the World Series on Data Virtualization. Suresh?
Thank you, Kim, and welcome again to our audience to this World Series on Data Virtualization. We're roughly at the halfway point of this series, and it has been fantastic so far. We've had about 6 or 7 episodes, alternating between leading analysts presenting their views on why data virtualization is becoming mainstream, and also very large and leading companies like Cisco Systems, Oppenheimer Funds, Arcable, sharing their knowledge of how they have actually put this technology to use initially in projects and scaling eventually to a data services platform. All of them have highlighted why it really matters to get agility into their business and how to reduce the cost of data integration and do so using data virtualization to tame the complexity and volume of information that is besetting every organization and preventing them from focusing on business value. So in this World Series, we have not only shared the technology frameworks and architectural frameworks, but also use cases, specifically the white papers by Mike Ferguson on analytical, operational, and data management uses, perspectives from Rick Vanderlans, from Barry Devlin, and some of our customers. And today we bring to you another session from a leading analyst firm, Forrester Research, from very much an application and enterprise architecture perspective from Randy Heffner. Before we start the session, a few words on Randy. Randy is one of the leading authorities on application architecture in the world today, and also enterprise architecture. And he serves those professionals by thinking about the traditional service-oriented architectures and data asset strategies, but from the perspective of business capabilities architecture. And he's written a lot about this. He's a very sought-after analyst. So while today's session will be relatively short, you will find a lot of value in how to think about data virtualization in the context of a business capability driven enterprise architecture. With that, I'd like to introduce Randy Heffner of Forrester Research to start this session and introduce the concept of data virtualization and the unified data layer. Randy?
Thank you, Suresh. It's fun to be here and talk about this stuff. You know, since the days of James Martin and information engineering, we've known that data is an important topic in IT, and data is more of a mess now than it was then. And in my remarks today, I want to focus in on one of the key ways that firms are getting a handle on data, and that's through virtualization and data services. So here's the problem, is you've got all this data that you have now spread out in a number of different siloed applications, and that's not all, because there's a bunch of data. I'll just put a couple of categories here: data from partners, data from anywhere in the world on some website somewhere that's of interest to your business. So there's new data that you need, and the sort of old line information engineering approach says what we want to do is somehow move to or rebuild or get this nirvana corporate data model, the right way to view all our data in an integrated way, so that we've got a good handle on it. It's all clean, coherent, and all put together in a in a good, clean way. And so great, that's where we are, that's where we want to be. Well, in this mix, here's we just fall through the crack here trying to get between the reality of where we are and where we want to be. And that's what happened with information engineering in the, in the late 80s, early 90s, and these big, huge corporate data modeling efforts that promised they'll help us out, but there was no way to get to the nice, clean view of corporate data. So what we do is we wind up with actually another problem, which is, well, we take that corporate data model and we throw it in the trash, but we still got all this data that we need to get to somehow and deal with. And so what we do is just have each project go grab whatever data it needs from whatever it needs it. And here's 3 examples of different things. Any kind of sort of SOA services, or maybe we have some analytics or reporting scenario, or some business scenario or application that needs to get data. And there's a bunch of other ways. Here's just 3 sample projects. But we got 90 ways that people are trying to use data, and it just creates a new spider web. And, well, it gets the job done, but it's very brittle. Change any of those siloed applications, change the requirements from any of these projects, and it can be very expensive to fix, aside from which it can just break along the way. So here's what you want. I mean, the vision hasn't changed a lot. We want to somehow hide all that mess behind a consistent modeled access to our data. Even if we can't achieve that full big corporate model, but somehow we want our applications and the ways we use data to at least think that they're working through a cleaner model of the data and insulate them from the actual mess of the silos that we have underneath, so that we can move our business forward somehow. Well, this is fundamentally an architectural problem. We saw the 90 ways to access kind of problem, and that's a programming answer. What we need is something more architectural. So let's think through this problem architecturally, and starting to do that, first let's go back to a 40-year-old vision. As long as I've been in the industry, we've been talking about we need good, strong layering in our applications, and so we go back farther than James Martin, and we get this nice 3-tiered layering, and that was often just a concept that we talked about. But what's happening is now in the industry we get some ways to actually achieve some of this layering in a strong way. And at the user interface level, there might be any number of different user interfaces now that compounds the problem: web, mobile, pervasive, meaning whatever we might have in the future, digital home, the computer inside your car that you think of as a navigation system, or some people put their iPads and mount that on their dash for their navigation system these days. All sorts of different ways of monitoring, pipelines and everything else that might be that in essence the user interface. Well, it turns out that SOA has been a good way, now the right design model, for between the user interface and business logic, so that we can package up SOA-based services for transactions, data, analytics, other types of ways of packaging the functionality and the business capabilities that we need. And now there's as well new capabilities for getting the right design model between business logic and the data access, data infrastructure level, wherever that data might be. And I'm going to call that, from an architecture perspective, data asset strategy. And I'll get back to that term at the end. But basically, what is now doable that has not been doable before in the days past in the industry is to use virtualization to provide an insulated layer, the right sort of view of the data that comes from anywhere down underneath. So the same virtualization concept is in a strong way what we were doing with SOA as well. So what we do at the data layer now is find ways to insulate the evolving business view, the higher level view that in this particular slide, as I'm looking at, SOA services might be using. Insulate that business view from the legacy apps underneath. Do whatever mapping and transformation that's necessary, and publish as business building blocks from the data that you need underneath without having to make the higher levels that are accessing through the data services layer, without having to make them aware of the mess of siloed and different kinds of data that we have underneath. So we did that with SOA, and that's proven very strong and a very effective model in the industry over the past few years. Same kind of thing is happening now between business logic and data. We're going to come back to this relationship between SOA and the data layer on a later slide, so don't get this three-layered model the way it is too firmly stuck in your head just yet. We'll come back to this, but this 40-year-old vision, this layering, is the right thing to do. But it's a 40-year-old vision, and the needs for modern solution architectures have expanded with a number of other technologies. So let's expand on that view and make it a 21st century vision. And that centers around business design focal points. And what I want to do is relate how these business design focal points present and provide other needs for data. And this is in a broader, this is from a broader set of work that I'm doing at Forrester called business capability architecture. But this reframes how we think about solution architecture. And these three elements we've talked about before are still here. I'm going to add some others. That's why it starts with number 2 versus starting with number 1. But we still have the user interface layer, but now that design point focuses on user roles, and these users need data to make decisions and take action. So we're designing around business points of making decisions and taking actions, and data is a key bit of that. Services now are focused around, and the business logic layers we look, is focused around SOA and transactions and analytics for how we use and update data as we're doing the work of our business processes. And then the data layer focuses in and may be specialized for one business capability or another, customer service versus product development versus manufacturing. So we need to bring specialized views of the enterprise data and external data as well to bear on particular transactions, particular user decisions and actions. But the model requires more than just these 3 design points these days. We need business processes which provide the context for determining how data is used. And there are a number of additional technologies that build on the foundation of these 4 that bring in other ways that we need to use data. There are a number of technologies that apply for control and optimization, business rules, events, business policies, embedded analytics, collaboration, and more that, again, are leveraging data for insight and decisions, or pulling data off of business processes or off of service requests, and these become new sources of data that are dynamic, flowing sources of data that we need to figure out how to use. We have more requirements to summarize data up into executive dashboards. And here I've been showing these design points within the context of a given business capability, customer care. One capability needs to connect to others, so we need edge connections to share data across organizational boundaries, whether internal or external to the company. So this is the 21st century vision that we can build toward and say got a number of different usage scenarios and ways that data needs to come to bear. All of this, whether you're working with the 40-year-old vision or the 21st century vision, puts a lot of emphasis and need on a strong data layer, a strong way to use our data, in a sense, from that logical corporate view. But as we've said, that logical corporate view is too big, too hard to build in one big go. So let's look a little more about that. Why is the data layer such a hard problem? Number one, it's very latency sensitive. So you put a lot of architecture and such in that data layer, you can quickly drive data response times the wrong direction. So you have to be very careful about that. Makes it a hard problem. But if you go straight to the physical data access reduces business agility. So, these two work at odds with each other. You know, we want physical access may give us the greatest performance, but more logical access runs into data latency issues. And then the problem just gets compounded because you have siloed, poor quality data across our legacy, and the need for speed in the business, the low tolerance for IT investments with high upfront risk and cost, like those old corporate data modeling initiatives. There's low tolerance for that. Well, what this adds up to is that there's no one solution to universal data access. We're going to need multiple ways to solve that data problem. So Forrester's looking broadly at this problem, and this is a Forrester Tech Radar chart, and that's focusing in on ways to solve the data problem. But what I want to point out is right up at the top and moving fast is data virtualization, largely in the form of data services platforms, as an answer, and as a primary answer, an important answer in one of the many approaches to solving the siloed data mess. And we want to focus in on that one today. The little double arrow thing is sort of a fast forward mark that says that this one's moving faster than some of the others, and it's in a growth phase, moving toward toward maturity in a strong way. So we'll come back to seeing what these kind of platforms look like. But the important point here is, amongst all the different ways that you can address data virtualization is a very important one to be focusing on. Well, let's come back to a third major architectural point, which is if there are multiple ways and multiple technologies you might be using in your environment, and we'll see some of that as we go into the customer case studies here, then you need to think more about the reference architecture by which you put those multiple pieces together. So another stream of work Forrester is working on data management reference architecture and trying to provide some broad structure so you can look at the problem from an a structure first perspective, and fit any products that you get and any components that you build into that model. So here's a quick run through our reference architecture. First of all, you have any number of original data sources: unstructured, structured data, semi-structured, event data, streaming data, internal data, external data, data anywhere in the world that's going to help your business. And that's riding on various kinds of data infrastructure, some of which you control, some of which you don't. But in order to use that data, you have to connect it into the particular solution area or business usage scenario. And there are a number of ways, whether it's business intelligence and analytics tools or traditional data access mechanisms, a number of different ways that you get to that data. But you got to be careful going straight to the original data sources. You may still need to do that in some cases, but for performance reasons, you may do a derived data source. MDM, data warehousing, these are derived data sources where you get a copy of the data. But for stronger real-time access and for less data movement kinds of scenarios, virtualized data access will be very important, and that's the one that we're focusing on today. But in between, you still got to be careful going straight to the original data sources. You need some form of data rationalization to clean data, to map between different data sources. So around those, there are a number of different data tooling and administration kinds of questions that you build. So derived data sources are a critical role in the future of data, and a primary way you may get to some of the data. But virtualized data also is very critical, and it may encompass and use derived data as well as other sources. We'll come back to that in just a second. So virtualized data can give you a broader view that encompasses original data sources, rationalized data, and derived data sources as well. So a key bit of infrastructure for virtualization is the data service platform. And what you see as you look at this, I'm not going to walk through all of the details here, but the key point from this slide is that it's bringing in a number of elements from the reference architecture that we just looked at. There's metadata repositories and cleansing mechanisms and a number of different ways of getting to different kinds of data, including pulling data from web pages and RSS feeds and streaming data and other things externally, or potentially from pulling data in from an SOA service and providing a virtualized view that maybe combines an SOA service with a database. That's a possibility. You got to make sure you think through your architecture and how you're doing these things, but that's another way to construct a virtualized data view. And maybe that SOA service comes from a partner or Facebook or something else. But the point is, what you get at the bottom is all of the different data services. What you get at the top is the top of that data sources, top you get the data references, the data usage scenarios that we talked about in the reference architecture. And in the middle, a data service platform provides a number of different capabilities for designing and constructing and building these views. So, come back to sort of that theoretical picture that we looked at earlier. How close do we get? What does this allow us to do when we have this kind of virtualized infrastructure? Well, now we're not going to throw our data model in the trash. We're not going to build it all at once. But we're not going to throw that idea and that effort in the trash. We still have to deal with all the legacy that we have. But what we're going to build over time in an evolutionary sort of way is a unified data layer. Think of it this way. What we'll do, rather than doing that whole corporate data model, is we'll do a bit of the corporate data model that we need for a solution today. And we'll tie that to the sources that we need, because we still have to get to all the legacy. And we'll build more of these over time. We'll evolve a set of data views, and our applications, the solutions that we're building, will go through that unified data layer to get to the data we need. So projects are getting what we wanted earlier, which was a clean view of data. We still have to use the legacy, but we're building that better, stronger corporate view, the way our data should be structured. We're building that over time. So let's wrap with some ways to think about how you would move from here, how you would do this. What would you do with one of these tools? How would it lead you to solving bigger problems over time? Well, with a data virtualization kind of strategy, you can solve some immediate project needs. Often that's a single view of a customer or product, supplier, whatever you might have. Or maybe there's some real-time analytic insights to make faster, better business decisions. Or maybe you need to bring data from somewhere else in the world, the web page, streaming feed. You solve some immediate problems. But if that's all you were doing, you would be in a limited way, because remember, virtualization is not the only thing that you need. You need to evolve toward a more comprehensive information architecture. So data virtualization can allow you to free your business processes from your legacy. You deliver business value now, you can fix the legacy over time and leverage funded projects to build toward that future architecture. And this bit about incrementally building the corporate data model, so here's how to think about a quick process for a mindset for how that works. You have a solution, you have a business need, a process need, and it deals with certain data entities and elements within those entities. You go out and you look and you say, where is that data? Where is it? Where does those entities, where do those elements reside? Where are they duplicated? Which is the data store of record? Particularly if we're going to update data, we've got to be clear on understanding where the data is coming from. Then let's define and clarify the context for data usage. How current does the data need to be? How quickly does it need to be updated? How many, if we have multiple copies, how fast do all the copies need to be updated? Then we can select a specific approach. Data virtualization is going to be an important option there as we're looking at the quality of service and addressing real-time scenarios. Then we can build and extend the architecture and infrastructure in an incremental way as we go forward, both building this incremental building out of the data model, as well as building a strong unified data layer and putting the right technologies, including data virtualization, into the box to solve those problems.
Thank you, Randy. That was an excellent session. I really particularly liked the aspect of how you've linked a 40-year-old vision for decoupling and some of the basic principles of service-oriented architecture and updated it to the 21st century with the business capability focus and the use of data virtualization to create what you call the data asset strategy. That was excellent. Now I'd like to follow that with a little bit of a Denodo perspective on the unified virtual data layer with the use of an example from one of our customers. When I think about what it means to have a unified virtual data layer and what is the role of data virtualization technology in it, it can be thought of at two levels. We all have different assets and investments that you've already made in integration technology. So for example, in this graph on the left side, you have a replication consolidation stack that's primarily serving business intelligence, reporting, analytics kinds of uses. So you may have ETL tools, data warehousing, lots of data marts, MDM, etc. And they are all accessing information from the same set of sources at the bottom, but primarily used for informational access. Out on the right side, again, you might be sourcing from the same source systems and operational systems, but there's another stack of integration technologies around enterprise service bus, EAI, business process management, or what's now combined into a SOA suite, primarily to serve business process and application integration. What a unified data layer vision is how to not only bring those two, but also in the middle provide an alternative way of looking at this information. So at the first level, data virtualization could be thought of as an alternative virtualization model of integration as opposed to replication, consolidation, or propagation. But at a more holistic level, the virtualization technology is also used to bring together the existing investments in middleware. So it provides universal data access, and it can feed either of the other two with that in a more normalized way, in a more abstracted, decoupled way. It can provide that unified virtual data layer that sources information not only from primary sources at the bottom, but also from secondary sources such as existing data warehouses or MDM hubs, or accessing information through a service bus or a message queue, and then exposing that as reusable data services through universal data publishing. So in this key point, you're now making the same logical information accessible not only to business intelligence and informational use, but also link that to operational processes. So some of the intelligence can be brought back not just for reporting in the traditional sense, but in an operational BI sense into the business process and vice versa. So that sort of a closed loop interaction between these applications is enabled by universal data publishing and a unified virtual data layer. Now, all this needs to then perform to the same high standards and perhaps even higher standards in the future. And that is done by understanding the various optimization techniques in real time, using caching, using scheduler support for different mixed workloads. Some workloads might be large data volumes or throughput. Some workloads might have high concurrency. Some workloads might have balancing of latency across multiple sources, etc. And from a governance perspective or metadata management perspective as well, this unified virtual data layer provides a unified entry point for visualizing lineage of data, change impact analysis, etc. It's not exactly a modeling tool for the source systems, but once you have your source systems, it provides all of the visualization of how they transform, combine, etc. to reach the applications. And also that information can be shared with other metadata and quality tools. So that's sort of the broad vision. So when you think about a data virtualization platform, it's pretty important to focus not only on the initial project needs. Do you have the right connectors? Does it have the right ease of use, features, performance, output formats, etc.? But also think about, can this platform support the evolution of this individual project to a unified virtual data layer? And so it's important to look for the breadth of connectivity options, the ability to deal with web and cloud information through web automation, the ability to connect to indexes and content management systems and social media, etc. And not only provide real-time optimization, but also the ability to cache and schedule support through batch transactions, the ability to publish this information in multiple different formats, whether it's SQL-oriented, relational, hierarchical query formats, multidimensional like MDX type queries, semantic queries, XQuery, etc., as well as being publishing to some of the more modern ways of interacting, or quickly becoming mainstream ways of interacting with data, such as mobile apps, iPad, etc. And then the governance features are extremely important, as is security. So another simpler way of sort of summarizing what I just said is, you are looking not only for this middle gray box in capabilities in a data virtualization platform, but you're also looking for the other two gray boxes here, to provide virtualized access to all data sources and to provide data services, to create this unified virtual data layer that sits between disparate data sources at the bottom and multiple data consumers at the top, working together with other technologies that you would have already invested in your enterprise. So let's take a look at one customer, a Biogen Idec, which is a leading pharmaceutical and biotechnology firm based in the Boston area of Massachusetts and operating worldwide in Switzerland and other countries, about 90 other countries in the world. Their challenges were changing requirements from the business, high implementation and support costs, and the time it took, given their constrained resources, to deliver those reports real time or in a very fast time frame, given the complexity among their different IT systems, their resellers, their partners, etc. And looking out to the future, they also wanted to be able to integrate unstructured and semi-structured data and data in the cloud. In order to do this, they were particularly initially focusing on a very specific problem, a very high visibility problem, which was about getting instant sales reporting in real time across their 90 countries in which they operate. But the challenge was they had a data, a Oracle e-business suite and data warehouses that focused on their North America budget, or some of their regional headquarters budget and sales in some primary countries, but a vast majority of the other countries where they were selling through wholesalers and distributors, the data was streaming in ad hoc in many different formats, and it took a lot of effort for several analysts, several days, to consolidate all that, find all the matches between products, different packaging, different formats of data, and truly present a unified view of sales reporting per drug, per channel, etc. And what data virtualization did was to enable access to these disparate sources from their original source systems, but present unified data views that did the data matching, did the data cleansing, and presented various different formats to access that in real time through Excel reports, through web-oriented dashboards, as well as through mobile applications, while at the same time taking the consolidated cleansed data, combined, and pushing it out for historical analysis into a data mart. And as exceptions were thrown, there were stewards who were notified of it and could very quickly make the changes required as some of the source systems changed to continue to provide this update. The benefits immediately noticeable to IT were now they were able to integrate diverse data sources The whole initial project took just 4 weeks, and very importantly, they were able to respond to change requests, whether it was new drugs, new distributors, changes in the way the systems operated, in a couple of days, in most cases, maximum less than a week. And the amount of effort it took to support the data virtualization platform was about 1/5 of a similar workload that was being handled by their traditional ETL kinds of platforms. So in terms of number of people and hours spent to maintain this. So the benefits to IT were overwhelming almost immediately. And the business started to see that they were getting fresh data, high quality data. Their concerns were being addressed, and they could now step up the pace at which they could request changes, and IT was up to the task of meeting it. And of course, they had more reliability on the data, and now the data was exposed in more formats for self-service enabled changes to the information. So the Biogen has gone on record to say that it's the whole data virtualization experience has provided 60% faster project introductions, time to market, using 40% less analyst time to support this. What's even more interesting is once they got the idea of how this could help on specific projects, lots of new projects started appearing where Biogen was increasingly reaching out to data virtualization. Since this original project started in the general administrative functions within Biogen, the initial other projects were also around HR reporting, real-time inventory, manufacturing, and regulatory compliance, and eventually spread to the research and discovery, which is the sort of the mainstream part of the business. But one of the points that's worth noting is as they started tackling some of these new use cases, they realized that in order to do this in a more smart way, they would first take this approach of build once and build reusable data services, and then recompose those data services into derived services for meeting many different use cases. So this particular graph shows how they could do so, for example, combining the financial data warehouse with their Oracle ERP system that had not only the financials but also the HR and talent pool, which is very important for a biotechnology firm. Combine them into workers hierarchy, project financials, and then interface with cloud applications for talent management, benefits, payroll, etc., to do integrated reporting. So this approach kept growing until they reached a very sophisticated unified data services kind of implementation. As you can see here, there are two primary technologies supporting this. Of course, there's a third one, which is ETL and data warehousing, which is represented at the bottom here. But in terms of services itself, they built reusable application or logic services that were separated from reusable data services. Oracle Fusion middleware providing the app services, and Denodo data virtualization providing the data services, which were then combined to create derived business services that were then focused around subject area or semantic domain information, such as whether it's by the business area like research and discovery, manufacturing, supply chain, compliance, G&A, or commercial, sales and marketing, but also used for different parts of the business process. So the point of sharing this is that as you think about what Randy said today, think that the end game might look something like this in your organization, but you might really need to get started with something that can justify the ROI in a few months and have a time to market of 4 to 6 weeks. So the results you can expect from data virtualization on the one hand are better quality information by accessing a diverse set of data sources and presenting them as integrated information across the silos, but also the lower cost of integration and the agility to change. But keep in mind that it starts to add new IT and business capabilities that eventually should lead you to this unified data layer. So with that in mind, we encourage you to think about those tactical projects or use cases that can leverage this technology, but consider a best-of-breed data virtualization platform that provides the full spectrum of data virtualization, data services, unstructured, and web integration, so that you can work towards the long-term vision that Randy outlined today of how to use this to build a unified data layer, to build a business capability driven enterprise architecture. And as you know, there's lots of sessions preceding the one today. The last 3 ones are highlighted on the screen, coming from both customers and analysts. Last week I was at the DAMA conference in London, UK, where the main theme of the conference, or the keynote, was on data virtualization. Participated in a panel with companies like Capgemini and the Carphone Warehouse. So lots of people are talking about this, and so please take advantage of the World Series sessions that have preceded as well as the ones that are coming up. And of course, if you need additional help to come up with ideas in your industry where the right use cases can be found for starting off on this journey, you can certainly look to the high-value uses of data virtualization, the 2-part white papers that were published earlier in the World Series on data virtualization. So again, thank you for attending today's session, and I'm going to pass this back to Kim Lukens, our moderator. Thank you.
Thank you, Randy and Suresh. We've had some great questions come in, and thanks to those of you who have submitted questions so far. We welcome your questions and encourage you to send any additional questions after the webinar to dvworldseries@denodo.com. We will be reviewing all questions coming in and ensure they are all personally responded to following the event. We encourage you to attend the entire World Series on data virtualization. If you have just joined the series, or if you have missed any of the earlier episodes in the series, please note that we have the recordings available on demand. To view them, visit our website and navigate from the home page banner on the World Series of Data Virtualization to the page on the series where you will find the schedule with links to all of the recordings. And mark your calendars for the rest of the World Series. We have some exciting episodes coming ahead. Our next episode will be on Tuesday, November 22nd, titled Automating Trace Process for Positive ROI, a financial services case study that will be presented by Steve Cohn from Direct Legal and Collections. This webinar will include a Denodo Advanced Technology session on advanced web automation, harnessing the web for virtual data services. This will then be followed by a webinar on November 30th titled Data Virtualization for Call Centers, Smart, Smarter, and Smarterer with Juan Manuel Mendero, Business Applications Manager with Jazztel, Global Call Centers. Well, we have reached the end of our webinar for today. I'd like to thank our speakers and thank all of you for your participation. Signing off until next week, this is your host, Kim Lukens.
The World Series on Data Virtualization is brought to you by Denodo Technologies, the leader in data virtualization, delivering unmatched flexibility, performance, and ROI.